During this segment, we'll simplify algebraic expressions. Before we simplify algebraic expressions, we need to go through a few vocabulary terms. First of all, we need to talk about what we mean by the word term, also what we mean by numerical coefficient, and what we mean by like terms and unlike terms. So let's begin with a definition of the word term. A term is a number or a product of number and variables raised to powers. For example, this is a term. It is the product of the number -3 and y. So here we have a term. I'd like to be able to identify the numerical coefficient of a term. And the numerical coefficient of a term is simply the numerical factor of a term. So let's take a moment and let's practice identifying the numerical coefficient, sometimes just called the coefficient. What is the numerical coefficient of this term? The numerical coefficient of this term is the numerical factor, and it is -3. So the numerical coefficient of this term is -3. Let's try that again. We'll just write down another term. Let's suppose I have 22z to the 4th power. This is a term. It's the product of a number and variables raised to powers. It is 22z to the 4th power. I'd like to find the numerical coefficient of this term, and that is the numerical factor of this term. Since this is 22 times z to the 4th power, the numerical coefficient is 22. Let's continue. We are finding numerical coefficients. Let's suppose I just have the term y. Now, y is the same as 1y. Very important thing for you to note. Y is the same as 1y because 1 times y is y. So what is the numerical coefficient of this term, or equivalently this term? It's an understood coefficient of 1. So the numerical coefficient is 1. What if we have, say, -x? There is my term, -x. I'd like to identify the numerical coefficient of this term. Well, you can think of -x as -1x if it helps. So what is the numerical coefficient? It is an understood -1. The numerical coefficient of this term, because it is the same as this, it is -1. And let's try one more time. Let's find one more numerical coefficient. Let's suppose I have the term x over 7. Now, if you need to, you may need to realize that this is the same as 1/7 times x. X over 7 is the same as 1/7 times x. So given that this is the same as this, it might be easier for you to see the numerical coefficient looking at it in this form. The numerical coefficient, which is the same as the numerical factor, is 1/7. That is the numerical coefficient, numerical factor. Now we know the definition of a term. We know what we mean by numerical coefficient. Let's talk about what we mean by like terms and also unlike terms. Terms that have the same exact variables raised to the same exact powers are called like terms. And if terms are not like terms, then they are unlike terms. Let's now practice identifying like terms or unlike terms. Let's identify whether these are like or unlike terms. So I have the term 5y I have the term negative y. Are these like or unlike terms? Once again, remember the definition of like terms. Terms that have the same variables raised to the same powers. Well, let's check that. This variable in this term is y. Same thing here, it's y. What's the power here? It's an understood power of 1, understood power of 1. So these are like terms. Let's try that again. Let's look at a pair of terms. Suppose I have negative 2x squared y and 6xy. This is a term and this is a term. Now, by the way, what is the numerical coefficient of this term? The numerical coefficient of this term is negative 2. And what is the numerical coefficient? Sometimes called the coefficient of this term. It is 6. So we have two terms. We want to identify whether these are like terms or unlike terms. So let's look at the variables and let's look at the exponents on the variables. I have a variable of x here and x here, a variable of y here and y here, but remember that's not enough. The variables have to be exactly the same and their exponents have to be exactly the same for us to have like terms. This variable x has an exponent of 2. This variable x has an understood exponent of 1. So we can stop right there. These are not like terms. One more time, don't forget, for you to have like terms, the variables and their exponents must be exactly the same. So these are unlike terms. An expression like this can be simplified by applying the distributive property. I have 3x plus 2x, and notice these two terms are like terms. By the distributive property, notice that I can write this as 3 plus 2, and then that quantity times x. That is 3 times x, or 3x, plus 2 times x, or 2x. And then notice, of course, 3 plus 2 is 5, so we have 5x. This process of simplifying when we have like terms is called combining like terms. Notice we combine these two like terms and we have that sum 5x. Now, how exactly did we combine the like terms? We, of course, used the distributive property, but can you see a way of going from here to here without taking that intermediate step? Well, notice the sum of the numerical coefficients, 3 and 2, is 5, and then it is multiplied by that common variable, x. So keep that in mind, and we will practice combining like terms. Let's suppose we have, say, the expression 8x cubed plus x cubed minus 11x cubed. This is an expression. Can we simplify this expression? Well, we can by combining any like terms. Notice this term, and in fact this term, all three of those terms are like terms, so we can combine them. Now, if it helps, this is 8x cubed plus, what is the numerical coefficient here? It is 1, so 1x cubed minus 11x cubed. Since they are all like terms, let's combine numerical coefficients and then multiply by the common variable raised to the power of 3, x cubed. This is then 8 plus 1, which is 9, and then 9 minus 11 is negative 2, so this is negative 2x cubed. So we combine the numerical coefficients, then we multiply it by that common variable factor, in this case, x cubed. We have combined like terms, and this simplifies to negative 2x cubed. Let's look at another example. We are simplifying by combining like terms. Let's suppose we have 6x plus 5/10 minus 4 3/10 x minus 4/10 x plus 3. Here we have an expression. We have 1, 2, 3, 4, 5 terms. Do we have any like terms? We'll simplify by combining any like terms. Well, let's see. This term, and this term, those are all like terms. So let's go ahead and combine them by first combining the numerical coefficients. I have 6 minus 4 3/10. Now, if you need to, go off to the side. And remember how you subtract decimals. You line up decimal points and line up place values. This is 5. 10 minus 3 is 7. Decimal point 5 minus 4 is 1. So 6 minus 4 3/10 is 1 7/10, and then minus another 4/10. Can you do that mentally? Subtract another 4/10 here, and we'll have 1 3/10. So we have 1 3/10 x. And that is the result of combining these like terms. Then notice I have 5/10 and I have 3 constants. What is 5/10 plus 3? It is 3 5/10. Now, can I go any further? Can I combine these two terms? The answer is no, because these are unlike terms and they cannot be combined. So we have simplified as much as possible. Let's review how we combine like terms. To combine like terms, add the numerical coefficients and multiply the result by the common variable factors. Now that we know how to combine like terms, let's practice translating phrases to algebraic expressions. Let's look at the following. twice a number decreased by 4. And let's let x represent our number. So let's translate this to an expression. How do we translate twice a number? That's 2 times, in our case, our number is x, so 2 times x, that's twice a number. And then decreased by 4, decreased means what operation? Decreased means subtraction, decreased by 4. You can write it as 2 times x minus 4, or if you'd like, 2 times x is the same as 2x minus 4. Now, is there any simplifying that can be done? The answer is no, these are unlike terms, so there we've translated and there's no simplifying that can be done. Let's now translate this phrase to an algebraic expression. The sum of 5 times a number and negative 2 plus 7 times a number. Think of what the word sum means. Here we are summing two things. What are the two things? The sum of 5 times a number and negative 2. So how can we represent 5 times a number? That is 5 times x, or 5x. So the sum of 5 times a number and negative 2. That's what we have so far. And then plus 7 times a number. Plus means addition. 7 times a number is 7 times x, or 7x. So we have the sum of 5 times a number and negative 2 plus 7 times a number. Can we simplify now this expression? The answer is yes, because we have a few like terms. 5x and 7x, that sum is 12x plus negative 2. Now, there are many ways of writing this. You can leave it as 12x plus negative 2. You can write it as 12x minus 2. Or you can actually write it as negative 2 plus 12x. Let me write this as or, just to show these are all okay. Or another way of writing this, put this term first. Negative 2 plus 12x. These are all equivalent. We've simplified, and in any of these cases, these are now all unlike terms, so we cannot simplify any further. All right, at this time, practice simplifying algebra.